Greetings, Professor. Myself Ashima, and this is our weekly development project status report for our project LAPD crime analysis. This presentation consists of about LAPD, about our project, our team, project status, project management practices and procedures, communication plan, and then the four phases: requirement, design, development, and testing phase, and then Power BI dashboard, project cost, and finally the strategies for opportunities and challenges encountered. LAPD. LAPD is a Los Angeles Police Department that is a law enforcement agency that ensures the public safety across Los Angeles, California. So, our project provides basic data driven solutions by using machine learning models for the crime predictions. Our main objective is to accurately predict the crime classification based on the historical data and then pinpoint the crime hotspots in the city of Los Angeles. Meet our team. Myself, Ashima, and I'm the team leader. Then we have Priyasha Sharma as business analyst, Kriti Komati as technical lead, Anujit Sivach as another business analyst. Our project status is on track. Now comes the project management practices and procedures. So, our project is divided into four main phases. The first is the requirement phase. It consists of basically the project proposal, project charter, and basically collection of the data set. The second is the design phase that includes data cleaning and data analysis. The third is the development phase that includes working with the machine learning models. We have basically worked with four machine learning models. We'll discuss them later in the presentation. And then finally, the testing phase that includes selection of the best model, visualizations, and then interpreting the results. Now comes the communication plan. Communication plan includes all the details of the meetings that are held, such as team meetings and client meetings, and mode of the communication is the Teams meeting. And the requirement phase. So basically, this data set comprises of all the criminal records in the city of Los Angeles dating back to year 2020. It contains around 8 million records. And after that, a comprehensive data dictionary is prepared that includes a detailed description of each attribute, making it easier to interpret and analyze the data. Moving on comes the design phase. The first part is data cleaning. We have a column named More Code that consists of specific codes that describes the important characteristics of time. That information was not enough. But after using some custom functions in the Jupyter notebook, we were able to get descriptions for each code and added them together. We also did some formatting in the time of crime occurrence column, making constant length for the columns and separating hours from the minutes. Some unusual white spaces have been removed from column name, location, and gross steed, and then finally some missing values are replaced so that we can proceed with data analysis. Now I would like to hand over to Anuji.
Thank you, Anshima. Myself, Anjit Samaj. I'm the business analyst within the team. Starting with the data analysis. For data analysis, we utilize Cpon and Matplotlib to implement charts in Jupyter Notebook. The first chart is a time series analysis that shows the number of crimes from the year 2020 to 2023. We used a line chart to plot the data, revealing an increase in crimes from 2020 to 2022, followed by a steep decrease in 2023. Next, we created a bar chart to count crimes based on the area name. The top three areas with the highest number of crimes were Central, 77th Street, and Pacific. We also developed a bar chart to display the count of the top 10 crimes, with vehicle theft, assault, and identity theft being the most common in Los Angeles. Moving to the next slide, we have three charts that describe about the demographic information about the victims. We have a histogram that is plotted using histplot from Seaborn that depicts the age classification of victims across crimes. We can see that ages 0 to 3 face the most common of crimes, followed by age 30. Next, we have a column chart created using count plot from Seaborn that classifies the number of crimes happened to each gender From the chart, we can see male victims are higher than other genders. Moving on, we have a column chart again using count plot that describes the number of crimes occurred on each ethnicity of people. From the graph, we can see that Hispanics and whites are the most number of victims. Now, I would like Priyasha to take over.
Thank you, Anujit. Greetings, Professor. My name is Priyasha Sharma, and I am the business analyst for this project. Let's delve into some more data analysis. So, for our spatial analysis, we have used Folium library in Python and used the latitude and longitude from the data in Folium marker function. Then took the latest 10,000 open cases from Los Angeles Police Department and plotted it on the map. Using the fast marker cluster function from Folium, the clusters disperse when an area is zoomed in and it is programmed to give all demographic information related to a particular crime. We also programmed the clusters in a way such that if there are less than 10 crimes, then the cluster will appear in green. If the cluster area contains from 11 to 100 crimes, the cluster is colored yellow, and if there are more than 100, then it is colored orange. Next, we have three charts that give information based on the weapons used for various crimes. The first is a bar chart plotted to display the top 10 weapons used for committing crimes in Los Angeles. Initially, we filtered the top 10 weapon types using n largest function, and the chart is plotted using the plot function from matplotlib. And the chart kind is set as bar to generate a bar chart based on the top 10 filtered weapon types. From the chart, we can see that the use of hands and feet accumulate the number one spot of weapon choice for committing crimes, followed by unknown weapons and verbal threats. Next, we have a box plot. Again, we filter the top 10 weapon types using n largest function, and the box chart is plotted using box plot from Seaborn. The chart depicts the distribution of victim ages for the top 10 weapons. The chart displays the mean age of victim for each weapon type. Finally, we have a pie chart plotted using matplotlib. Along with the use of a filter, we are able to see the top 5 weapons used for crimes in each area. From the example shown, the filter and OK button are created through IPY widgets. We can see that the area Newton has 63.2% of crimes that occurred using hands and feet, followed by unknown weapons and handgun with 12% and 11% respectively. Now, Kriti will continue with the development phase.
Thank you, Priyasha. Greetings, Professor. I am Kriti Komati and I am the developer for this project. Now, we will proceed to the development phase where we developed the machine learning models for our project. First, we start with preparing the data. We first removed irrelevant columns using the drop function, then employed label encoding with scikit-learn's label encoder for categorical values. After this, we split date components day, month, year using pandas datetime function, then utilized a simple imputer to fill not applicable and unknown values with most frequent for specific models, and at last we fed the pre-processed data into both training and testing sets. The first machine learning model we would like to discuss is the random forest. We have used pandas, numpy and scikit-learn's modules including random forest classifier to build this model. First, we split data into 70% training and 30% test sets, focusing on the crime codes column, then filtered unknown values, predicted results with random forest classifier, and stored it in the YPRED. After this, we calculated accuracy using accuracy score and generated a classification report, achieving 99.45% accuracy. Then we also visualized important features with a bar chart highlighting crime codes as the most significant. Now, Ashima will continue with the other model.
Thanks, Kriti. Now we have K nearest neighbor model. We import the necessary libraries and modules for the KNN model. Initially with the feature set X derived by excluding the target column which holds a description for the crimes. The data is then split into training and testing subsets using 70:30 ratio. The KNN classifier is then initiated with the specific number of neighbors using K-neighbor classifier. We have implemented around 3,000 neighbors as the total count of the data is more than 5 million. Once our model is trained on the training data, it proceeds to make the predictions on the test set. The accuracy of this prediction is calculated by using the accuracy score, confusion matrix, and a classification report. The result for this model shows a poor performance with a score of 23.55 accuracy. We have also a line chart that describes the optimal number of neighbors for the model, which is one that suggests that it is expected to have a poor performance. Now I would like to hand over to Anujit.
Thank you, Ashima. Now we have naive-based models for machine learning. We import the necessary libraries such as Gaussian MB module for naive-based model. The data is then split into training and testing subsets using a 70:30 ratio as in other models. For this model, we use CRM CD column. Then we have initialized the Gaussian NB function as the classifier. Then the prediction is performed for the test dataset and the results of accuracy and confusion matrix is generated. From the result, we see an abnormal 99.99% in accuracy, which indicates that there might be possible overfitting for the model. Now, I would like Priyasha to continue with the next model.
Thank you, Anujit. For the last model for machine learning, we have logistic regression, which is retrieved from sklearn library. The data is split into training and testing subsets using a 70:30 ratio. The model is used with an iteration of 10,000 along with random state of 42, which means that the algorithm will iterate up to 10,000 times to try to find the best coefficients for the model. The random state parameter is used to seed the random number generator. The prediction is then performed on the test dataset using log_reg.predict, and then the accuracy and the confusion matrix is generated. We observe a decent accuracy of 81.93%. We can also see a correlation matrix which reveals relationships between variables with color indicating strength and direction, where red colors signifies positive correlation, whereas blue denotes negative correlation. Now, I would like to hand over to Kriti. Thank you.
Thank you, Priyasha. Next, we will decide the model that we will use for our objective. We have selected the random forest model because the random forest model excels with 99.3% precision, ensuring efficient resource allocation for proactive crime measures. Its 99.4% recall minimizes oversight, capturing a high percentage of actual crimes. The F1 score at 99.31% signifies a balanced strength in precision and recall, showcasing practical robustness. Overall accuracy stands impressively at 99.4%. Now, we'll also discuss why we didn't select other models. We have excluded naive Bayes for feature independence concerns, logistic regression for linear assumption limitations, and KNN for low accuracy in complex crime datasets. Next, we are on the process of preparing the dashboard for the project using Power BI. Currently, the dashboard contains a map of Los Angeles with all the crimes, along with analysis of crimes based on the case status and premise description. All the charts are linked, and a slicer for modifying the date is also added to the dashboard. We are yet to add more features for the final presentation. Now, let's discuss the project cost. The project has been allocated a budget of $38,000. Ongoing monitoring and transparent reporting are vital to uphold financial control and stay within budget for the project. Next, we'll discuss entrepreneurial strategies for opportunities in Los Angeles crime analysis that include data acquisition and analysis, technology integration, monitoring and control, scalability, and many more. We also encountered challenges along with the solutions such as crime data often has the class imbalance issues, with rare crimes being underrepresented and complex models can be hard to explain and may affect trust. Our solution address class imbalance and enhance model interpretability, ensuring our crime prediction system is both accurate and transparent. For our activities in the upcoming weeks, we are aiming to complete the dashboard in Power BI and work on the final presentation. We are delighted to have questions if any. Thank you.